Today we'll be looking about graphing rational functions. We'll be spending a few days on this, and this is a very big topic, again, for calculus, a skill that you will need. Now in Algebra 2, you learned how to graph rational functions, so this is nothing really new. Just remember, you need a little bit of information. Now the best way to graph rational functions is to use the following. You will need some asymptotes and some points. You get those, you can graph it. Now what we're going to do is we're going to take a look at this example. We're going to graph the function -2 over x minus 1. Now the first thing we're going to do is find the domain. Now the domain is very easy. You look at the bottom. It's where the bottom cannot equal 0, because the only domain restriction is when the bottom can't equal 0. And that's easy to solve. So if I say x minus 1 cannot equal 0, we're saying x cannot equal 1. So what's the domain? Every number but 1. And you can write that as saying from -infinity to 1 or from 1 to infinity. And there's our domain. Now, if you remember to get the wholes, that involves looking at the factors. Does anything cancel? Okay, and here unfortunately nothing cancels. The x minus 1 is not going to cancel. We'll see an example of this later on. So right now we say there's no wholes in this case. Now, next we go to our vertical asymptote. Now the vertical asymptote deals with, well, remember, it's an asymptote. It's what x cannot be. And in this case, x cannot be 1, so therefore our vertical asymptote is x equals 1. Now, both wholes and the domain both come from your domain, from the denominator right here. Okay? So, now kind of a rule. Okay, we'll talk about this later on. You can be a whole or you can be an asymptote. You can't be both, okay? So x equals 1, it's going to be our asymptote. It can't be a whole at the same time. Next, what we look for is a horizontal asymptote. And you probably remember this from last year. Hopefully, this is one of the big ones. Looking at the vertical asymptote, you're looking at the degree on top, and you're going to compare that with the degree on bottom. Now the degree on top is 0, the degree on bottom is 1. So we say the degree on top is less than the degree on bottom. And if the degree on bottom is bigger, or if the degree on top is less than the degree on bottom, we say the vertical asymptote is, the horizontal asymptote is y equals 0. So we get y equals 0. So if the degree on top is less than the degree on the bottom, we say it's 0. Now, next we take a look at the next part. Will it cross the horizontal asymptote? Now, this is actually going to give us a point. These are asymptotes. This is going to give us our first point right now, if we could. So what you're going to do is you're going to find out if this is true, you're going to take that 0, y equals 0, and you're going to set that equal to the equation, -2 over x minus 1. And when you cross multiply, you're going to get 0 times x minus 1, which is 0 equals -2. That's not true, so this will not cross. They will not cross the horizontal asymptote. Now, as you may recall also from last year, slant asymptote. If you have a horizontal asymptote, there is none. And that is because we have a horizontal asymptote. To get the y-intercept, very easy. Let the x equal 0 and just plug it in. Y equals -2 over 0 minus 1, and I get +2. Now, which is really interesting because that gives us our first point, 0, 2, and we're going to sketch that. To get the x-intercept, you let y equal 0. And if we do that, we get 0 equals -2 over x minus 1. Now, if you notice, that's the same as our horizontal asymptote, so we know that's not going to work for us either. Anyways, does that make sense? So we don't have to redo that. Now, what I'm going to do next is I'm going to start sketching it. First thing what I'm going to list are my asymptotes. Okay, my asymptotes are x equals 1, y equals 0. Next, any points I might have. Now my only point that I do have is my y-intercept from down below, 0, 2, and I'm going to graph that. So when I sketch this out, At x equals 1, I have an asymptote. Y equals 0. There's my horizontal asymptote. There's my x and y axis. There. Next, I graph a point. The only point I have is the point 0, 2. 0, 2. There it is. Now, what's very important to remember is functions love asymptotes. They want to go as close as possible to them. And asymptotes, if you draw it correctly, will tell you which way to go. As I go from my point towards my vertical asymptote, I can't cross it. So it's going to go up the asymptote here. Same thing with the horizontal asymptote. I'm going to go down towards the horizontal asymptote. And since I never cross it, we can just keep going and we get closer and closer and closer and closer. So there's that part. Now, the next thing I need to do, now I have a choice here. One, I could pick another point on the other side here. But another way I can do it is to use multiplicity. And what I mean by multiplicity is if I go back to the vertical asymptote, just like when we did polynomials, this has a degree of 1 on bottom, has a multiplicity of 1, m1. And if remember, if it's an odd number, if it's positive on the other side, if on one side it goes up of the asymptote, on the other side it has to go down. So it has to go down here. And where's the only place I can put it? I can't put it up here because I can't cross this asymptote, the horizontal. So the only place I can put it is in this little section down here. And there's our graph. So take a look at this note, see if you need to redo them, and that'll be fine. We'll try it again, and that's okay. And then move on. Okay? All right, now, for the next few problems, we're going to do these on our own paper. Make sure we have enough room, okay? So let's take out our own sheet of paper and let's try number 2. Now we're still going to show all the work that we normally would need to do. Now number 2 is the equation y equals 3 over x minus 2 squared. Now the first thing I want to find out is my domain. What's the one thing x can't be? Easy. You can do that in your head. X can't equal 2. So my domain, negative infinity to 2 or 2 to infinity. Next, do we have any holes? Now to get a hole, I would need factors cancel. So no factors cancel. So there will be no holes. On the next example, we'll take a look at one where factors do cancel. We'll take a look at one with a hole on it, okay? Now, so no holes, we got our domain. The next one we have our vertical asymptote. So the x equals 2. It wasn't a hole, so that x can't equal 2 must be our vertical asymptote. Remember the rule. You can be a hole, you can be an asymptote. You can't be an asymptote. Alright, so x equals 2 is our vertical asymptote. Now, the other thing is this now has multiplicity. It's m2. And we'll talk about that at the end here. Next, we need our horizontal asymptote. To do that, look at the degree on top and look at the degree on bottom. Now, the degree on top again is 0. On bottom, be careful, it's 2. Still less than it. And if it's less, we get y equals 0. Some of you guys made it Bobo Botten eats RC or eat DC last year. And you can still use that if you want to. Now, because we have a horizontal, there is no slant asymptote. Next, we need to get the y-intercept. To get the y-intercept, let x equal 0. Easy to do. We get y equals 3 over 0 minus 2 squared, which becomes 3/4. So my y-intercept is 0, 3/4. Our x-intercept, let y equal 0. We get 0 equals 3 over x minus 2 squared. And again, it's not going to happen. Same reason over here, horizontal asymptote. We forgot to check if it'll cross, but this won't cross. So none. That can't work, because if I multiply, I get 0 equals 3. So next what I do is I sketch it. List out all my asymptotes. You can abbreviate it. My asymptotes are x equals 2, it's m2, y equals 0, and I get any points that I might found, which is the point 0, 3/4. Okay. So our next thing we have to do, sketch it. X equals 2. Be careful, I'm going to list that as M2 down here. We'll talk about that in a second. Y equals 0, and my only point, 0, 3/4. Remember, functions are attracted to asymptotes, up and up. Now, here's what the M2 says. M2 says, just like when we did polynomials, if it's positive on one side, it's going to be positive on the other side. So if it goes up the asymptote here, it has to go up the asymptote on the other side. So that's the only place I can put it. Can't put it down here. So, and there's our graph. So check 1 and 2 again if you need to, and then go to part 2 when we're going to take a look at a couple more with one with a horizontal where it crosses and one where we actually have a hole here. We'll talk about those next.